Welcome to qnawire.
So once again, welcome to a new problem. This time we have a cylinder. So we have a cylinder that's standing, and then of course on top of it we have a sphere that's sitting on top of the cylinder, and then in the next instance we have another cylinder that's lying flat, and there's a sphere that's sitting on that cylinder. There's a sphere that's sitting on that cylinder. The other case is the same. We have a sphere sitting right there. The mass of the sphere is m. This is the mass. And then also the radius of the sphere is r. We want to make certain assumptions. We have another case. The top sphere, the sphere, one sphere is sitting on the other one, and we want to make sure that they have the same dimensions in terms of extended radius. So this one goes like that, and if you think about it, the span, the entire span, we want it to be roughly the same. So they're the same like that. So it goes that way. So these are two cases. The first case and the second case. In the second case, we have a mass small m, and we also have a radius small r. The height is h for this one, and the height is also h for that one. So that's what we're dealing with in this particular problem. We want to find the center of mass. So again, that's our target. Our goal is to figure out what the center of mass in the y direction. Of course, we're saying that the cylinder is standing that way, so we can measure things in the y direction. So in that sense, we do have a y center of mass is the same as m1 y1 plus m2 y2 over the sum of the two masses together, and y1 and y2, assuming this is your x-axis and that's your y-axis, this is your this is your y-axis and this is your x-axis. So this is going to be y1 for the first object, and this is going to be y2 for the second object. Those are the heights that we're dealing with. And then we can think of this as m1, and this mass is m2. So that's relevant in the formula. And this is part A, and this is part B. So you're looking at it that way. We have two objects, object 1 and object 2. So we want to find the center of mass of these two objects. So just to clarify, the formula is general. It's a general formula, so we don't have to split that both ways like that. We just want to make sure that this is the y-axis. This is the y-axis, and this is the x-axis. So this is A and this is B. We want to find the center of mass of each one of these items. So we'll start with part A. The x center of mass is 0 for part A because it looks like this. If you think about it, this is your y, and this is your x. This is 0. So in the x direction, we'll just add 0. The y center of mass, on the other hand, is going to be a little bit different. The y center of mass is going to be a little bit different. Let's simplify this. So we're saying the y center of mass, we have M1 would be the cylinder. So, you have M1 and M2. So M1 is a cylinder, but then in terms of the y direction, it's 0, plus M2 is the mass of the sphere. So this is the mass of the sphere, and it's at a position h/2 plus r. And the reason why it's h/2 plus r is because look at this. This height is the radius. The radius of the cylinder is at r, and then of course the y1 becomes h/2 plus r. That's the position of the sorry, not y1, y2. So we just want to clarify, M1 is the mass of the cylinder, and then M2 is m, y1 is 0, y2 is h/2 plus r. That's what we're dealing with. Then you want to divide by the two masses. So dividing by the two masses, we get m plus capital M, because M1 is the same as small m. And then now we can simplify and say y center of mass is the same as capital M over m plus m, h plus r. So the center of mass for A is going to be the x center of mass, y center of mass, z center of mass. You already know the x and the z is 0, so we'll only focus on the middle part, 0 comma m over m plus capital M. This should have been capital M, and then h/2 plus r, comma 0. So we want to have a square bracket here, so we distinguish what's going on in the problem. So then we box it like that. That's for the first object, object A. And then we are in part B. So in part B, this is what you're seeing. That's what you're seeing for part B. So if you think about it, this is x, you have the y-axis. So we have M1 is M, M2 is capital M, that's the sphere, this is the cylinder, this is the sphere, that's M2, capital M. And then the radius, we also have the radius, so y1 is 0, because that's the cylinder. Y2 is r plus capital R. So this one is capital R, and this one is small r. So you have two r. Then if you want to get the y2 for that, it's the small r over the capital R, just the same way we did for the other one. In the case of the other one, in h, we had to divide h by 2 and then add it to the radius of the sphere. That's the same thing we're doing here. We're taking the radius of the sphere and then adding it to this height, half of the base half of the base of the cylinder when it's lying on its back is r. So that's what we're dealing with. And then, of course, the next step is just to plug in the numbers. Y center of mass is the same as m1 y1 plus m2 y2 all over m1 plus m2, and then we do our replacements. So m 0 plus capital M, y2 is r plus capital R all over m plus capital M, and so this becomes m r plus capital R all over small m plus capital M. That's Y center of mass. So the solution for this one is the X center of mass and Y center of mass is going to be 0 comma m capital M. So you want to distinguish the M's. There's a smaller one and the capital one. This is capital M, R plus R, small m plus capital M, like that. And that's our center of mass. Of course, the Z, you can include the Z center of mass, but that's just going to be 0 anyways. So once again, we had a problem, two problems in one. The first one, we had a cylinder that's standing up, and then, we had a cylinder that's lying on its back. We had a sphere on top of each one of the cylinders. So we used the formula to determine the center of mass. We're interested in the Y center of mass for each one because the X is in the Z will be 0. So for the first case, Y1 is the displacement position of the cylinder relative to the origin, which is 0. The mass of the sphere is capital M. The mass of the cylinder is small m. Y2 is the position, half of the height of the cylinder, and then half of the height of the sphere, which is r. So we use that, we plug it in. Then we get the Y center of mass being this value. With the X and the Z being 0, we repeat the same process this time, plugging in small r plus capital R for Y2, because it's half of the base of the cylinder, which is small r, and then half of the diameter of the sphere, which is capital R. So then we simplify that and get the center of mass. So hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.